Hello everyone, welcome to Logistic Regression with Python application class. In this class, I will be using default data to show you how to apply logistic regression. I will illustrate the concept of logistic regression using a simulated dataset. And we will be interested in predicting whether an individual will default on his or her credit card payment on the basis of annual income and monthly credit card balance. Let's first import the libraries and then start importing the data. So these are going to be the libraries that I will be using. So I start importing them, and then my data set is called CC default. Okay, so this is my data set. As you can see, there are two categorical variables, default and student. I will now go ahead and convert those variables to dummy variables. So I created two dummies. The first one is called default yes, and the second one is called student yes. So this code is slightly different than what I did before. It helps me create dummies for all categorical variables in the data set and at the same time. So it creates two dummies in one code. Let's start our analysis by taking a look at the correlation of the variables. As you can see, default, which is the third line here, is positively correlated with balance, negatively correlated with income, and positively correlated with being a student or not. Now let's create some scatter plots to see the relationship between the variables. Let's start with balance. Okay, so this chart shows the relationship between the balance and default. So y-axis shows the default and x-axis shows the balance. So y is equal to 0 means that the customer did not default, and y is equals to 1 means that the customer defaulted. So as you can see, the defaulted customers have the tendency to have a higher balance, but people who did not default have a tendency to have lower balance. So there's going to be a kind of an S-shaped curve here. This is just to explore the data set. Now let's do the same thing with income variable. So I'm going to copy and paste this here and change this balance to income and run the code again. This time, people who did not default seems to have a higher income, and people who defaulted seems to have a lower income. These are just some exploratory analyses. Now I'm going to draw a couple of box plots to explore the data from a different perspective. On x-axis, we see the dummy variable default. So this one shows that the people defaulted. This one shows people did not default. As you can see, people who defaulted has on average less income, and people who did not default on average have higher income, which we expected before. Now let's do the same thing with balance. So I'm going to copy and paste it here and change income to balance. This is again what I expected. People who defaulted seems to have higher balance. People who did not default seems to have lower balance. Okay, now let's take a look at the descriptive statistics of the data set. So we have 5,000 data. Mean balance is $3,999 and mean income is $39,012. And then standard deviation, minimum, maximum are all stated here. Now let's run a logistic regression without train test split. And then I will do the same thing with train and test split. So I had to put a dot here instead of underscore. Okay, so this is the regression output that we got. There are a couple of things to note here. First of all, there is only one exploratory variable here, which is balance. So I'm using only balance here. And the second is I'm using all of the observations here. So I'm not dividing the data into two pieces like train and test splits, but I'm using the whole data set to come up with some estimation. So just using these numbers, so intercept seems to be negative 3.81, and the slope of balance, the coefficient of balance is 0.0005. So this gives us a model something like this. Basically, beta 0, B0 is negative 3.81 and B1 is 0.005. So if you substitute everything, this is the model we have right now. So if somehow I'm supposed to estimate the probability of default of some customer who is balanced, who is X value is $10,000, I substitute here 10,000 instead of X. Whatever number I get from this probability will be the probability of default for that customer. So if you do the calculation, this is going to give you 0.76. 0.76 is the probability of default for a customer whose balance is $10,000. Now let's take a look at the predicted values. So this gives me the predicted values of default. So let me show you a scatter plot which shows the predicted values and the default values, and it will illustrate my ultimate situation. So this is the ultimate situation of my estimation. So the blue points are the actual data and the red points are the values that I predicted, I estimated. So for every single balance, I have a corresponding estimated probability of default, and there will be a cutoff. So let's assume that the cutoff is 0.5. This means that all of the predicted values beyond that cutoff point, which means these values, are going to be assumed to be defaulting, and all of the predicted values below this point, which means more or less people whose balance is less than, let's say, $8,000, are assumed to be non-defaulting. I'm using only one predictor here. I can copy and paste this to change the predictor to income. So this is, I can change it to income and do all the analysis with income too, but I will not continue with all the variables. So as you can see in this situation, the intercept and income has changed, or I can add them both. So I can make default yes plus 1 stands for intercept, income, balance, and for example, I can add also the dummy variable. So if you run this regression, this is the regression with all of my predictor values. So I use all of the predictors, income, balance, and dummy variable. And number of observations 5,000 people. So I did not use any train and test split. There is something called pseudo R-square here, which is kind of an analogy to R-square in linear regression. So it's very close to 1, which means that my regression is quite successful. But basically, in machine learning, we do these analyses with train and test split. Now I'm going to do same analysis with train and test split, dividing the data from 60%. So 60% of the data is going to be my train set, and 40% of the data is going to be my test set. So this is going to be my y variable, which is the target that I'm explaining. The explanatory variables, which is the matrix X, is composed of all the columns except the default yes column. So now let's write the code for train and test split. So I'm going to copy this part from my previous classes, which is kind of fixed. So there's nothing interesting in this data set. So this is train test split. Run this. The code is working. Now I'm going to run the logistic regression for my data set. Okay, so these are the intercept and the slope coefficients of my model. Let's take a look at the predictive performance of my model. Here I selected 4 random records from the dataset. These are as follows. So this is the observation 6, this is observation 728, 2721 and 4808. So these are the observations. These are their actual defaults. So the first 3 did not defaulted, but the last one did. P1 corresponds to their probability of default. As you can see, these are very infinitesimal numbers. The model is predicting that these guys are not going to default. So the first 3 guys. The last one is 0.85, so it's 85%. So the model is predicting that this guy is going to default, and in reality, it defaulted already. Now let's take a look at the performance, the overall performance of the model. As you can see, the overall performance of my model is almost perfect. It is mainly because this data is a simulated data set. So now let's take a look at the confusion matrix. So the first row refers to actual non-defaults and the second row refers to actual defaults. So out of these 1701, my model correctly predicts 1698 non-defaults, and out of 299 defaults, my model correctly predicts 297, which is almost very close to perfect. I'm going to write a tiny little note here which shows you in a bit more colorful way what is what in this matrix. Basically, this 1698 refers to predicted zeros out of actuals, and these are the predicted ones out of actuals. Okay, in this video we reviewed how to run logistic regression where output variable is binary in Python. I hope you enjoyed the video. See you in the next videos. Bye.